In this video, I'm going to demonstrate how to program a relay in the BW500. The same information for the BW500 also applies to the BW500L unless otherwise indicated. Programming a BW500 relay can be considered after the basic functionality of the scale has been proven out. In this BW500, I have running currently at a little less than 500 tons an hour. And so far it has accumulated, close to 4,200 tons of product. The current belt loading is about 50 pounds per foot, and the current belt speed is about 330 feet per minute. Let's look at the setup of this BW500. It's programmed for a design rate of 1,000 tons per hour. It's programmed for a design speed of about 333 feet per minute. That equates to a design belt loading of 100 pounds per foot. So what we're going to do for this video is we're going to program a relay for warning when the belt loading is too low, and we're going to provide a warning when the belt loading is too high. Okay, so the design criteria is 100 pounds per foot, and we're going to be programming the relay as a percentage of the design belt loading. Relay terminals in the BW500 are marked RLY 1 through 5. BW500 will have only 2 relays, so RLY1, RLY2. This is an older version of the motherboard, so some of the relays are on this row of terminal strips, and then the rest of the relays are over here on this row of terminal strips. On the newer BW500 and BW500L, all of the relays are going to be found on this row of terminal strips. So it's right near where the power energy source for the BW500 is connected. It's right across from where the energy source is connected. I've already got this started by connecting a couple of wires to relay 1, which is these 2 terminals here. Let's go over the parameters in the BW500 and BW500L that pertain to programming the relays. All of these parameters are index parameters. The BW500 has 5 relays. The BW500L has 2 relays. So these indexes would be index 1 through 5 for the BW500 and index 1 and 2 for the BW500L. Parameter 100 is the relay function parameter. This tells the BW500 what function that you are going to be programming the relay to provide a switch change of state. There's 4 choices for the BW500L, 1, 2, 3, and 4 for rate, load, speed, and diagnostic. All of the other ones apply only to the BW500. For this demonstration, we're going to be programming the relay for option 2, which is belt loading. Parameter 101 is our high alarm set point. The value that we program is a percent value of the full scale. So in this case, full scale would be design belt loading, which we saw in the integrator was 100 pounds per foot. Parameter 102 is the low alarm set point that's used to trigger the switch change of state. Again, this is the percentage of full scale In this case, we're using belt loading, which has a design value of 100 pounds per foot. Parameter 107 is the relay alarm condition. There's three choices. You can program it to warn on a high and low alarm, high only, or low only. Parameter 117 is the relay deadpan to prevent relay chatter. The default value is 3% of full scale. That usually works just fine, but you have the option of adjusting the range within 1 to 10% of full scale. Parameter 118 is relay logic. Positive logic means that the relay is open and the relay will close on the alarm condition. Negative logic is just the reverse. The relay is open and it will close on the alarm condition. So you have both choices here. Parameter 119 is used to override the current state of the relay. So let's say, for example, you want to test connected circuitry to the relay. You can use parameter 119 to switch on and switch off the alarm. Or let's say you have an alarm condition that's sounding a horn and you're getting tired of listening to it. You can switch off the alarm using this parameter. Then when you're finished, you just return parameter 119 to a value of 0 and it'll go back to normal operation. And a final comment on relay programming, as it states here in the suggestion, program the relays after the basic functionality of the scale is working as expected. All right, that's it for relay parameters. Let me finish getting the BW500 wired up and we'll start programming. Okay, I have the BW500. Relay 1 wired to a continuity tester. This is just a battery powered device and it should light up right here when the switch is closed for the alarm condition. So let's get relay 1 programmed. Go to parameter 100 and I'm going to change that to a value of 2 for belt loading. And right away it went into the alarm. I'm not sure why, but it did. Then I'm going to go to parameter 101. And I'm on index 1. For the high alarm condition, let's say I've got an application where the downstream process cannot handle more than 80% of the design belt load, 80 pounds per foot. So I'm going to want to program the high alarm for 80%. The default value is 100%, so we're going to change this to 80. Okay, let's go to parameter 102-1 for index 1. And let's say the low alarm condition that I want to use is, let me give an example here. Let's say we want to indicate that we have a plugged feed chute to this conveyor. And let's say that that plugged feed chute occurs when a clamshell gate is open to dose product from a silo. And we want to warn when the belt loading gets below 17%. of the design belt loading of 100 pounds per foot. The many of the weighbridges that Siemens offers, like the MSI weighbridge and the MMI weighbridge, are accurate for a 5-to-1 belt loading range. So in this case, it'd be 20 to 100 pounds per foot for our 5-to-1 belt loading range. So let's say I want to program this alarm for 17%. So I'm going to go into edit mode, program it for 17%. All right. Now I'm going to go to the next parameter, 107, and I'm going to indicate on a low alarm only. So I'm going to change this to a value of 3. The default is 1, both high and low. Okay, the next parameter is deadband. I'm going to keep it at the 3% of full scale. Okay, the next parameter is parameter 118. Since the relay is closed now, I'm going to change this to reverse, so it should change to opened. And the light went off. So let's leave it like that and see if we get our alarm condition to work correctly here. All right, I'm going to put this back into run mode. Our relay should be programmed. And I'm going to switch the screen to alt display so I can see belt loading. Right now we're running at about 50 pounds per foot. So as the belt loading starts dropping down, I can see that the relay turned on because I'm now below 17 pounds per foot. And I'm starting to bring it back up very, very slowly. And when it gets back to 3% above that 17 pounds per foot, which would be right around 20 pounds per foot, this relay should turn back off. And it did. Okay, let's go to the high alarm side. So I want to go up to about 80 pounds per foot. Okay, now I'm going to program the relay for a high alarm only. So I'm going to go back to the parameter 107. Whoops. Okay, right now I'm on low only, so I'm going to change it to high only. I'm on index 1, enter. Change this to a 2, so now it's going to alarm only on high. Then let's put it back into run mode. And I'm going to switch the display to belt loading. And we'll increase the belt loading, and 80%, which we programmed previously, should be the set point. So when I get to 80% of 100 pounds per foot, which is 80 pounds per foot, this alarm relay should change state. Okay, and it did. So now it's an alarm, And that means I would have to bring the belt loading down below 3% below that, which would be about 77 pounds per foot. And this alarm should turn off. So let's just slowly bring it down and see if it does that. And I drop below 77 pounds per foot, which is my 3% dead band below the set point of 80%. And the relay has turned off. Okay, there you have it. Programming a BW500 relay for belt loading out of range. That concludes this recording. I hope you enjoyed it.